For decades, if you were a scientist who wanted to study UFO phenomena, you had one option: end your career. The topic was radioactive. Academics who touched it faced ridicule, funding cuts, and professional isolation. One atmospheric physicist who investigated UFO reports in the 1960s was so marginalized that he died at age 51, his work ignored by the very institutions that should have taken it seriously. That was the old world. Now look at what is happening. Harvard University has built an AI-powered observatory that has cataloged over 500,000 aerial objects in less than a year. A Stanford professor with over 300 research publications is using the world's most sensitive mass spectrometry equipment to analyze alleged UFO materials. Peer-reviewed physics papers are calculating flight characteristics that exceed anything humans have ever built by orders of magnitude. The Pentagon has admitted that 21 cases from 2024 alone are what they call true anomalies. Cases that the director of their UFO office, a man with a physics background and decades in the intelligence community, says he does not understand. Something has fundamentally changed. This is the story of how artificial intelligence and rigorous physics transformed UFO research from fringe speculation into legitimate science, and why the questions being asked now are more profound than anything that came before. To understand how dramatic this shift has been, you need to understand what came before. For most of the 20th century, scientists avoided UFO research like a disease. The phenomenon was tangled up with tabloid sensationalism, conspiracy theories, and true believers who cared more about faith than evidence. Serious researchers who engaged with the topic faced immediate professional consequences. Then three things happened in 2017. The New York Times revealed that the Pentagon had been running a secret program called the Advanced Aerospace Threat Identification Program to investigate UFO encounters. The U.S. Navy released authenticated videos of unexplained aerial objects captured by fighter pilots. An interstellar object named Oumuamua passed through our solar system with properties that challenged assumptions about what travels between stars. Suddenly, the conversation changed. In 2023, NASA convened an independent study team of 16 experts, including scientists and a former astronaut, specifically to examine the UFO question. Their conclusion was unambiguous. Artificial intelligence and machine learning are essential tools for identifying rare occurrences in the data. The panel noted something critical. UFO analysis is more limited by the quality of data than by the availability of techniques. That was a scientific statement. It acknowledged the inquiry as legitimate while identifying the real problem. The data was not good enough. Not yet. That problem is now being solved. In July 2021, Harvard astrophysicist Avi Loeb launched something unprecedented, the Galileo Project, the first systematic scientific research program designed to search for evidence of extraterrestrial technology near Earth. The approach was deliberately different from government investigations. No classified information, no secondhand testimonies, no secrecy. The project would follow the evidence from its own sensors and share data openly with the public. They built an observatory unlike anything that existed before. Standard astronomical observatories point at small portions of the sky, searching for distant objects. The Galileo Observatory monitors the entire sky continuously. It collects infrared, optical, radio, magnetic, and audio data around the clock. The core component looks like something from science fiction. An array of 8 infrared cameras mounted on a hemispherical structure that provides 360-degree coverage. The team nicknamed it Dalek, after the Doctor Who villain because it resembles R2-D2. But the real breakthrough is not the hardware. It is artificial intelligence, AI. During just the commissioning period from January to May 2024, the system cataloged approximately 500,000 aerial objects. No human could analyze that volume of data. The AI does it automatically. The machine learning algorithms track and identify objects in real time. They differentiate known objects like birds, aircraft, balloons, and satellites from unknown objects. They flag anomalous behavior patterns for human review. They maintain a consistency that would be impossible for people watching screens 24 hours a day. When something unfamiliar appears, the system reports it. The AI does not get tired. It does not get distracted. It does not have preconceptions about what should or should not exist. The project is now expanding. Additional observatories are being established in Colorado and Pennsylvania. A network of AI-powered sensors is being built to watch the skies continuously. We have never had this capability before. While AI handles the detection problem, physics is handling a different question. What do we actually know about how these objects behave? The most thoroughly analyzed case in scientific literature is the Nimitz encounter from November 2004. For 2 weeks, the USS Nimitz Carrier Strike Group tracked unidentified objects off the California coast. The case involved multiple Navy pilots, radar operators on multiple ships, and infrared video footage that was later released by the Pentagon. Dr. Kevin Knuth decided to do what no one had done rigorously before: apply physics. Knuth is a professor of physics at the University at Albany. He previously worked at NASA Ames Research Center. He is not a UFO enthusiast. He is a physicist who saw data that deserved proper analysis. Working with colleagues, Knuth published a peer-reviewed paper presenting the calculations. The results were extraordinary. The objects tracked on radar descended from 28,000 feet to sea level in approximately 0.78 seconds. Let that sink in. To cover that distance in that time, at the midpoint of descent, the object would have been traveling at approximately 35,000 miles per hour. Through the atmosphere, with no sonic boom, no visible heat signature, no apparent propulsion system. The calculated acceleration was approximately 5,370 g. For comparison, a modern F-35 fighter jet experiences structural failure at around 13.5 g. Human pilots lose consciousness at sustained accelerations far below that. The object was pulling 400 times the force that would destroy our most advanced aircraft. The estimated power output to achieve this was over 1.1 gigawatts, roughly the output of a nuclear reactor. Gigawatts. And here is what makes the physics truly strange. There was no exhaust, no heat signature despite gigawatt power levels, no sonic boom despite hypersonic speeds, and no plasma formation that should occur when an object moves that fast through air. These are not violations of physics, but they are characteristics that no known human technology can produce. Knuth made an observation that captures the implications. If these accelerations were sustainable in space, such craft could easily reach relativistic speeds within minutes to hours. They could cover interstellar distances in days to weeks. The physics suggests capabilities we understand. Physics can tell us how something moved, but what was it made of? Dr. Gary Nolan at Stanford University has been trying to answer that question. Nolan is one of the most credentialed scientists in America. Over 300 research publications, 40 US patents, founder of 8 biotech companies, named one of Stanford's top 25 inventors, recipient of the Department of Defense's Teal Innovator Award. Around 2012, people associated with the CIA and aerospace corporations approached him. They had heard about his laboratory's capabilities. He had developed one of the world's most sensitive mass spectrometry platforms, technology capable of measuring isotopic ratios and elemental compositions at parts per billion sensitivity. They wanted him to analyze materials allegedly recovered from UFO incidents. One case Nolan examined is remarkably well documented. On December 17, 1977, at least 11 witnesses in Council Bluffs, Iowa, watched a red, luminous mass fall from the sky. Police arrived within minutes to find 35 to 55 pounds of molten metal still smoldering in a field. Initial investigations ruled out satellites, meteor impacts, thermite reactions, and hoaxes. NASA and the Air Force examined the material and could not explain its origin. Nolan and his colleagues, including veteran UFO researcher Jacques Vallée, published their findings in Progress in Aerospace Sciences in January 2022. It was the first peer-reviewed paper on UFO materials in a major aerospace journal. What they found was strange. The material was steel with an unusual composition, but the really anomalous feature was the mixing. The spatial distribution of elements throughout the material was highly inhomogeneous. The components were incompletely mixed. Nolan explained why this matters. When you manufacture something, you mix the components thoroughly. Incomplete mixing creates structural weaknesses, cracks, failures. No industrial process produces material that is deliberately incompletely mixed. Yet this material fell molten from the sky. Multiple witnesses watched it happen, and its internal structure was inconsistent with any known manufacturing technique. Nolan has also analyzed materials from a 1957 incident in Brazil. Mass spectrometry revealed unexpected isotopic deviations, high-purity silicon that diverged from natural forms, isotopic ratios that did not match terrestrial or known meteoritic compositions. The significance of isotopic anomalies is profound. Artificially manipulating isotopic ratios requires technology far beyond current human capability. We are talking about costs potentially in the trillions of dollars to produce even cubic centimeters of such material. The materials analysis does not prove extraterrestrial origin, but it rules out many prosaic explanations. Something unusual is happening. While some researchers build new detection systems, others are looking backward in time. Dr. Beatrice Villaroel at the Nordic Institute for Theoretical Physics in Stockholm realized something important. We have astronomical photographs from before humans put anything in space. Today, when we see a brief flash of light in the sky, we know it might be sunlight reflecting off a satellite or space debris. But the photographic plates from the 1950s predate Sputnik. Anything anomalous on those plates cannot be human spacecraft. It did not exist yet. The VASCO project, short for Vanishing and Appearing Sources During a Century of Observations, compares these historical photographs with modern surveys. In 2021, Villaroel's team published findings in Scientific Reports, which is part of the Nature Journal portfolio. They found something extraordinary. On April 12, 1950, a photographic plate from Palomar Observatory captured 9 point-like objects that appeared simultaneously in a small region of sky. Those 9 objects were absent on a plate taken 30 minutes earlier. They were absent on a plate taken 6 days later. They have never reappeared in any subsequent survey. The team systematically ruled out explanations. Not asteroids or meteoroids. Those would leave motion streaks during a 50-minute exposure. Not flaring stars. The detection rate is far too low to explain 9 simultaneous events. Not photographic defects. The objects show proper star-like profiles. Not satellites. Humans had no satellites until 1957. The statistical probability of this occurring by random chance is approximately 1 in 10,000. Even more intriguing, VASCO found similar anomalies on plates from July 19th and July 27th, 1952. Those dates coincide precisely with the Washington, D.C. UFO flap, one of the most famous UFO events in American history, when radar operators and pilots reported multiple mysterious objects over the nation's capital. In 2025, Villaroel's team published additional analysis. They compared transient events in Earth's shadow, where solar reflections cannot occur, versus illuminated regions. The results showed a clear deficit of transients in the shadow zone. Approximately 1/3 were missing. That pattern suggests at least 1/3 of the phenomena were caused by solar reflections from highly reflective objects in high orbits. Flat, reflective objects, not round asteroids or dust grains. We do not know what they were, but they were there before we put anything in space. While independent scientists pursue these questions, the government has been conducting its own investigation. The All-Domain Anomaly Resolution Office, known as AARO, was established in 2022 to investigate UFO reports. As of October 2024, they have received over 1,600 reports. Most can be explained: balloons, birds, drones, satellites, conventional aircraft, but not all. In November 2024, AARO Director John Kozlowski made a remarkable statement. He said there are interesting cases that he, with his physics and engineering background and time in the intelligence community, does not understand. And he does not know anybody else who understands them either. 21 cases from 2024 alone were classified as true anomalies requiring further investigation. These include 3 reports of pilots being trailed or shadowed by unidentified objects, multiple eyewitness accounts with corroborating data, video footage, characteristics inconsistent with any known aircraft or natural phenomenon. The official position is that AARO has discovered no evidence of extraterrestrial beings, activity, or technology. But that statement exists alongside the admission that the director himself cannot explain what he is seeing. Half of all investigated cases remain unexplained due to insufficient data. The 21 true anomalies are cases where the data exists, and still no explanation fits. The government also revealed that elements within the US government had previously proposed a program codename Kona Blue, specifically designed to reverse engineer extraterrestrial craft. The Department of Homeland Security rejected the proposal as without merit. But the fact that such a program was formally proposed demonstrates how seriously some officials take the possibility. Something fundamental has changed. For the first time in history, we have AI systems capable of monitoring the entire sky continuously, cataloging hundreds of thousands of objects, and flagging genuine anomalies without human bias or fatigue. We have peer-reviewed physics papers calculating flight characteristics that exceed our best technology by orders of magnitude. We have materials analysis from one of the world's most advanced laboratories revealing compositions that are inconsistent with known manufacturing processes. We have historical astronomical data showing phenomena from before the space age that defy conventional explanation. And we have government officials admitting, on the record, that cases exist which they cannot explain. None of this proves extraterrestrial visitors. The phenomena may have explanations we have not yet discovered. Unknown atmospheric processes, secret military technology, something else entirely. But the questions being asked now are different from the questions asked before. They are being asked by physicists with peer-reviewed publications, by Stanford professors with hundreds of patents, by Harvard observatories with AI systems processing 500,000 data points, by astronomers analyzing photographic evidence that predates human spaceflight. The stigma that destroyed careers for decades is fading. The tools that make rigorous investigation possible finally exist. The institutions that once dismissed the topic are now funding research. We do not know what these phenomena are, but for the first time, we have the capability to find out, and that changes everything.